In this video, we're going to look at how to find the equation of an exponential function given either the intercept and a point or 2 points. So before we do this with exponential, we're going to review what we did with linear functions to do the same thing. So linear function, find a linear equation that goes through the point 210 and has a slope of 6. So remember, our general form is going to be y equals mx plus b. So we're going to start with that every time. So we're going to start with y equals mx plus b. We know our slope and we know a point. So we're going to plug in this for 2 for x, 10 for y, 6 for m. So 10 equals 6 times 2 plus b. And then we went ahead and solved for b. 10 equals 12 plus b. b equals -2. So we have m, we have b. We would write our equation as y equals 6x minus 2. And that's how we found our linear equation if we knew the slope and we were given a point. So let's look at how we would do this with an exponential function given the same information. So we're going to call this curve fitting with an intercept and a point. How to find an exponential function that goes through a y-intercept and a point. Step 1, we're going to start with our general form, y equals a times b to the power of x. Step 2, we're going to replace a with the y-intercept value, or the initial. Step 3, we'll replace both x and y respectively. So whatever the x is in the point, we'll go in for x. What the y is, we'll go in for y. And then we will solve for b by dividing by a and then taking the indicated root, whatever x is. All right, so step 1, we're going to start with our general form, y equals ab to the power of x. We're dealing with exponential, so we want to make sure we start with an exponential point or equation. Next, I'm going to replace everything I know. So here's my y value, here's my x value, here's my a value. So let's go ahead and do that. 2,916 is equal to 12 times b, we don't know, to the power of x, which is 5. So I'm going to go ahead and solve. So first thing we're going to do is divide by 12. Divide by 12. Remember, I'm solving for b. It's going to give me 243 is equal to b to the 5th. Now, I have to solve for b, which means I have to undo that power of 5. To undo the power of 5, just like undoing the power of 2, we would square root. To undo the power of 5, we're going to take a 5th root. So we're going to go ahead and take a 5th root of our value. So the 5th root of the power of 5 cancels out, leaving us with b. And the 5th root of 243, I'm going to go ahead and just review how we do that on the calculator. I'm going to hit 5 because I want the 5th root. Then I'm going to hit the math key right here. And I'm going to go down to option 5, which has a little x as the number for the radical. And I'm going to put in my 243. That gives me a power of 3, or it's not a power of 3, but the value of 3. So now I have my b. I have my a. Gives me my equation y equals 12 times 3 to the power of x. And I can go ahead and check this by plugging in 5 for x, and I should get an output of 2,916. Example 2. Find the exponential function that goes through 0, 700, and 4, 1.12. This here is our y-intercept. So that's our a. The reason it's our y-intercept is it's the value of y when x is 0. Go ahead and start with y equals a times b to the x. I'm going to substitute in the other point. So I'm going to substitute 1.12 in for y. My a value is 700. My b value, don't know, to the power of 4. First is to divide by a, which was 700. That gives us a value of 1.12 divided by 700, 0.0016, which is equal to b to the 4th. To undo the 4th power, we're going to take a 4th root. I'm going to use my calculator to do so. And that's going to give us a b value of 0.2. So now I'm going to write my equation. I know what A is. A was 700. B is 0.2 to the power of x. Why don't you go ahead and pause the video here and try our practice problem. All right, so there's our answer for practice problem on the bottom of that sheet. Next, we're going to go ahead and we're going to look at finding an exponential curve if we know the 2 points that it goes through. So we're going to remind ourselves again with our linear equation on how to do that linearly. Helps us understand our exponential. Find a linear equation that passes through 319 and 1040. First thing we had to do was find our slope. So we're going to go ahead and do y2 minus y1 over x2 minus x1. That's going to give us 21 over 7, giving us a slope of 3. Now that I have 3, I can pick one of my points and start with mx plus b. 19 goes in for y. M is 3 we just found. X is also 3 plus our value of b. Solve for b. So 19 equals 9 plus b. B equals 10. And then now that we have b, we have m, we went ahead and wrote our equation y equals 3x plus 10. We're going to do something very similar with our exponential functions. Find an exponential function given 2 points. So now we're going to take our 2 points and do something like we just did. Because it's exponential, we're going to start with y equals ab to the x. Now this process is a little different. We're going to set up 2 separate equations that are in exponential using our points. Now, the one thing I suggest doing makes this possible is we're going to look at the x values. Whichever x value is higher, we're going to start with that one first. So we're going to take this and write a generic formula. So y is 48. So we're going to say 48 equals ab to the power of 5. So we don't know a and b. We only know the y and the x. Then we're going to write a second equation using our other point. So 6 equals ab to the second. So again, 5 comma 48, 2 comma 6, those are my 2 points. Now, why did we put our exponent, our equation with our larger exponent on top? Here's why. What we're going to do is we're going to do elimination, but because we're dealing with exponential, we're going to do it through division rather than addition and subtraction. So what we're going to do is we're going to divide this equation by this equation. If we do that, so let's go ahead and divide them out. 48 divided by 6 is 8. Our a divided by a cancels out. So now I'm down to just my b value. And my exponent rule tells us to subtract these exponents. So 5 minus 2 leaves me with b to the third power. If we had switched these the equations around, I would have ended up with a negative exponent, which would have caused quite a headache. So we want to ensure that when we subtract our exponents, we're going to end up with a positive value. Now that I'm here, I can solve for b by taking a third root. That's going to leave me with b equals 2. Now that I have b, I can solve for a. So now I'm going to take one of my points and my b value to solve for a. So let's go ahead and we'll start with y equals ab to the x. I'm going to put 6 in for y. A, I don't know. B now is 2, and x is 2. All right, let's go ahead and solve. So 6 stays 6, a stays a, 2 to the second power is 4. Then I'm going to divide by 4. And in doing so, I'm going to get 1.5 equals A. Now that I have A and I have B, I can go ahead and write y equals 1.5 times 2 to the power of x. And again, I can take either of these points, substitute it in, and make sure that that equation works, just to verify. So there's my equation through my 2 points. Let's go ahead and do one more. Find the exponential function that would go through the points 9, 11,444, 5, 292.97. All right, so I'm going to start with my higher x value as my top equation. So I'm going to have 11,444 equals AB to the power of 9. And on the bottom, 292.97 equals AB to the 5th. Now when I divide these, so I divide top by bottom, I'm going to end up with some weird numbers, 39.06202. I am going to want to write as many digits as I have. It's going to allow me to get the most accurate answer. A divided by A cancels out, and then I subtract my exponents, giving me B to the 4th. Now I'm going to take my 4th root. So when I take my 4th root, I want to be as accurate as I can. So I am going to type in all of these numbers. And that's going to give me B equals 2.4999992. Now here we're just going to use our idea that we're using exponential. So the value that B is really important. We're going to just say that this is 2.5. If we get something that's got a decimal that's crazy close to something, we're just going to use it. So 2.5 is what we're going to say B is. Now I have my B. I'm going to pick a point. The point that I'm going to pick is this one. Doesn't matter. So y equals AB to the power of x. 11,444 equals A times 2.5 to the power of 9. So I just got to grab my calculator for that. 2.5 to the power of 9. 11,444 equals A times 3814.697266. So I divide that crazy number. 3814.697266. On both sides, 3814.697266. And that is going to give me an A value of 2.9999975,936, which we are going to say is 3. Leaving us with our equation of y equals 3 times 2.5 to the power of x. Now, if we went ahead and checked and tried to plug in our value, let's say we plug in 9, 3 times 2.5 to the power of 9. Notice I don't get 11,444 on the dot. I get something really, really close. For our purposes, that is the curve, that is the fit. So we are not going to go further. Remember, we had to round just the slightest for both of these to give us these numbers. That's why this is slightly off. And that is how we can find an exponential function given 2 points. So we've looked at given a point and an intercept, as well as given 2 points.